Okay, good morning. We'll start our lecture in a minute. So now, the last and the remaining thing that we have in CG is this unit. As you can see on your computer screen, that is illumination model and surface rendering methods. So if we go according to your syllabus, this is the last thing that we need to study. And yeah, so the yesterday's example that we had to take on magnitude in the denominator part, I have updated ABC according to that, and similarly I have calculated the same thing according to the concept. So you try that thing, and remaining things would be easier for you. So I think so that today is our last lecture for in this week, and then we have three more lectures in the next week. So we need to finish this unit also. So total, I think 4 lectures we have, and after that we have practical week. So in the practical week, if students are coming, then uh, we'll see what we can do. And also, we have to spare 1 day for the quiz, or 20 or 30 minutes for the quiz. So many things are like pending, and we need to finish this thing. Okay, so without wasting much time, we can now start because many students have already joined, and we'll see this thing. What is this illumination model and surface rendering methods? Okay, so yeah, so as you can see, illumination models and surface rendering methods. So many a times it might happen like you don't want a typical like circle that looks a bit unrealistic, and sometimes you want something to be very realistic, and you want to render something that gives you some shade, that gives you something that looks like very real to you. Because in the real world, what happens is you are getting the light source out of the sun, and what you see is a very realistic thing. Like if you look at the river, and or if you look at some surface or something, you get some sort of information, or you get some light intensities that comes out of that particular surface, whatever surface it may be. It can be wood or plastic or shiny surface. So you see that thing, and it looks to your eyes like a bit more realistic. So if you want to do the similar kind of thing, because now we have seen this thing from the very typical things that we had in our hand to model this thing. Okay, we were not having this kind of properties where we can model like model an object surface that would reflect the light as the real object do. So now what? So these are the concepts that we can apply, and we can model it in a our programming language or something. So illumination models and these methods. So illumination models are nothing but obviously, if one word, if I say that it's illuminate or illumination, then this would come in your mind that okay, we are talking about something to be displayed or something that we can see. Okay, if we say that this thing is getting illuminated, so that is visible to us, and that is a very simple thing. So which are the models that could create this thing for us, because everything that we look at in the CG, it's not like that it comes directly, but there is some we can say maths or some logic behind it. So how we can, so that is fine if you know it, that okay, these are the things that we have in real world. But what if we want to model the same thing in based on the programming things? So for to do so, we need to learn, we need to go in a bit like the detail, and we need to learn this thing in that way only. So as you can see, the very first point says that in order to achieve realism in computer generated image, we need to apply the natural lighting effect to the surface of the objects. Okay, so a very simple thing. What we see and what we try to understand is okay. Some if we look at some surface or a river or something, we try to understand, okay, these are the lights, or these are the things that is falling on that particular thing, and these are the things, or the light or whatever thing is getting reflected, you are able to see that kind of intensity coming out of that surface, whatever ball or river or whatever it is. So that kind of natural lightning effects are needed to be created. Okay, so to achieve this thing, illumination models are used to calculate the amount of light. So now to do so, how, if you are working on an application where you are included in a river and an object is there, so you try to create something that would like calculate the amount of reflected light that falls on that certain position of a river or an object. So to do so, we have this illumination model. Okay, so if we have something that can calculate the amount of the light that is being reflected or that this surface is reflecting, that is a very good thing. Okay, and likewise, but obviously, if we talk about our computer display or something, then we have pixels. And now, if I want to do this thing, I need to give something, some information to this pixel so that that particular pixel would give some particular intensity. If I say as compared to the other pixel, it will give something different, and you need to calculate that pixel uh, intensity only. So that is the basic thing that we need. So what it says, in other words, they provide the way to compute the color on a pixel of a surface. So if you have surface and like few pixels are that are illuminating that particular object or something, and for that pixel, you if you have some way to calculate some intensity for that particular thing, then it would be a very good thing. So using the illumination model for computing the color of the every pixel is costly, because at the end some calculation is needed. It's needed to be computed, or it's needed to be done at your side or at the programming part or something. So if you talk about a scenario where you have so many things in a single frame, or so many things are to be illuminated, so in that case, for each and every pixel you need to do that calculation, and you need to put a loop, whatever you say. It would take more computation power, and at the end it will take more time if you just simply run it on a CPU or something. I'm not talking about cloud or something. Okay, where it rises, or where it would use some GPU or something. So if I talk about a typical scenario that you have CPU or something, then it will be a very resource hungry application. Okay, so many things are to be eliminated. So in this case, surface rendering methods are used to interpolate illumination values computed by certain spatial pixels. Okay, so now to reduce this cost, like computation power or something, we have the surface rendering methods. Okay, so why we use this thing? They are used to interpolate illumination values, okay, computed for certain pixels. So now whatever things have been calculated further than from the we are getting from the neighbor pixel or something, what we do is we try to give the same information to the neighbor pixel, and likewise we go on and we try to create a complete scenario where we are getting where we have multiple things to be illuminated. And instead of calculating the same value again and again, what we are doing is we are interpolating multiple values that we might have in our scenario. So that is the basic thing in this illumination model and surface rendering matter. And then we can go ahead with the thing with the concepts that we have, or the types of models that we generally use to generate a realistic thing. Okay, we'll see this thing also, and we'll go ahead with that. Okay, fine. So next, what determines the color of a position at a surface? Okay, so many things matters, because based on the scenario that you want to create, it all depends on the material properties. Okay, it is a shiny object. What made wood, what make wood look different than a metallic object? Okay, because at some point you want your scenario, or you want your object to illuminate only a certain amount of light or something that is coming to that surface, and that is getting reflected. Because if you talk about wood or shiny object, both have different properties, because shiny object would reflect that thing more, and what matte or wood surface would be doing the same thing in a different manner. So if you have this information with you, you can similarly model the same scenario and you can put it to test. Okay, so now the next point says is the object position with respect to the light source. Okay, now one more thing is important in this perspective, because if we talk about a light source, there can be, it can come from any direction. If we talk about sun, then we have it lights that is like falling on, like it is dispersed. We are not getting it at a particular point or something. If we talk about torch, then we try to like incident the light on a particular surface or a particular point. But if we talk about a general light source, then in this case, like things would be different. So object position with respect to the light source and also with respect to other objects. So that is how like it will create some shadows or something, and that makes us like it makes this particular thing very realistic. We are creating shadows and reflections and so many things. If you are putting it together, then you'd be getting very good things. Generally, like developers, game developers use this thing to create such kind of effects, because like you have heard about one technology that is ray tracing or something. So ray tracing is nothing but it tries to get the light source and from where your like light is falling or something on that surface, and how it is getting illuminated or how it is displaying this thing. So you might get some shadow, you might get some reflection, and overall it looks very realistic. Okay, so you might have gone through some gaming technologies where they have this RTX on and RTX off kind of thing. So yeah, like Nvidia or something is using this technology. I don't exactly remember it, but if they put this thing into that particular perspective, then it looks it looks very good. Okay, so feature of light source, color of light, strength of light, etc. Okay, so but obviously this color of light is also important, because whenever we have different color of light that is falling on that surface, and if you say like the surface of the object that you are using is of some blue or green or whatever color, and your incident light is also of some other color instead of white or the natural light that you have. So in that case, the thing that would get illuminated, the light that would get illuminated would be of different color, because at the end combination would be a different thing. The strength of light and so many things comes into the picture, because like now you'll understand this. Okay, now these are the very new things that we cannot do in the graphics library, but obviously because we don't have this kind of feature. So these are the things that we have included in the chapter, and few simple syntax that I have kept in this PPT is based on the OpenGL. So we'll try to learn this thing, the orientation of the viewing plane. Okay, so again, like if I talk about a viewing plane or perspective of a person that is sitting at some particular position and tries to look at that object or something, then it is of like it is very important whenever you keep this thing into the picture. Okay, illumination models, and then we have light source. So illumination models for computational efficiency, computer graphics applications usually employ approximation model of the real physical illumination process. It tries to simulate, it tries to put the same scenario that happens in the real world, and tries to approximate the models according to the natural things. Okay, and likewise, we don't have to go into that much detail that where we want our pixels to generate that much intensity that could give us some realistic thing. But instead of that, if you have this kind of modeling techniques, what you generally do is you just employ this thing. Suppose if I talk about diffuse reflection or ambient light or something, specular reflection or something, so in that case that would be a different case, because uh, if we can model this thing directly in our code, then we need not have to like calculate its intensity based on the pixels or something. So these are the things that you can easily do in OpenGL. Some of you might be interested in graphical things or something. They can go ahead with their like research based, or like they can pursue their final year project in this projects too. Okay, whatever the current trend it might be. So to get more realistic picture, model that are closer to the actual physical lightning model should be developed. As I say, like you are looking at the things based on the initial light that you are getting out of the sun. So if you can model something that is very close to the actual physical lighting, then you could get a more realistic like scenario. But they are costly, and rendering a single frame may take a lot of time. Okay, so but obviously if you try to do so, then you need that kind of graphics card or that kind of technology to be installed. As I said, RTX, ray tracing, and something that they are putting in the gaming technology, where if you are walking, if your character is walking in the game or something, then if some, if on the land some water is there or something, then you'd be able to see the reflection of the real world in that water too. So you can understand it, that how advanced this thing is. And then it requires that kind of rendering technique, because in the like single frame so many things are getting processed. Okay, sometime whenever you progress your character in the game, you just see that thing, that like trees, if suppose trees are there or some buildings are there in the game or something, it gets like illuminated one by one whenever you progress in that with that character or something. So if you are able to see this thing, that after some second it is getting displayed on the computer screen, that is based on this frame thing, because it is not able to render all the information that is present in that game. Okay, but instead of that, it is trying to render things based on the like thing that you are doing in the game. Okay. And then light sources. Okay, a light source can be defined with the following parameters. Okay, so basic thing, many things of like that comes out of this topic you already know. So we'll just go fast with it. It can be defined with the following parameter: position, but obviously color of the emitted light, because if it is a natural lighting condition, then it is fine. But if you are putting it from some other LEDs or something, then it matters then. The emission direction. Okay, emission direction is also very important whenever we talk about this thing. Okay, and then the shape of the light source. So these are the things. And let's see, basic thing is like in OpenGL we have some functions where you can like simply give this parameters instead of like thinking much about it. Acha, ek sun hoga, and if it is a torch or some other light source, how we can do this thing. It is nothing. It is very simple. Like you just have functions for this thing, and you can similarly give some parameters where you would just simply take it and put it in your application. Okay, but again, there is one thing that you need to follow. You have to go from the very basic, because so many things, so many projects have been developed in OpenGL. So if you go from basic, then you'd be able to understand it, else you'll get confused. Because a normal like C program that contains this graphics.h library, and then you try to model something, it is relatively simple as compared to the OpenGL. Okay, so OpenGL would take like so many lines of code to completely make a scenario. Okay. And then point light source described by a position and a light color. So light rays are emitted from a point light source in all the directions. So one such example we have is sun. Okay, so it is not like that, but it is emitting this thing in a single direction or something. So the rays that you are getting out of that single light source falls in all the direction. It is generally used to identify the object illuminated by the point source. The position information is important in this case. Okay, so but obviously like if you look at a car and something is getting reflected, some particular stuff is getting reflected, and you would be able to easily make out that okay, our light is falling from this particular direction at this particular stage. तो आपको पता चल जाएगा okay, now we are getting the light from this particular direction. Okay, you can generally imagine this thing. And then infinitely distant light sources. Okay, so now they can be simulated by a single emission distance direction vector. The direction is used to calculate the amount of light received at a position. Okay, it might happen that you have certain objects in your scenario where and you have given one light source, so the nearby objects would be taking more light as compared to the far distant object. So in that case, you need this kind of thing where you can generally give even like equally, or you can give this intensities based on that lighting condition. Okay, if it is near, then you have to model it in that way. If it is far, then you have to calculate the amount of light received at a position. Okay, so you can generally simulate this thing. And then light intensity attenuation. Now what is attenuation? So we'll understand this thing. The same thing as we have seen in this previous slide will come over here in the form of attenuation. So as the light emitted from a light source travels to space, its intensity decreases. Okay, a very simple thing. So this phenomena is the thing what it is called as attenuation. Okay. So now one simple example that you can see on the on your computer screen is this thing. That is a traffic light will not be able to illuminate an object 2 kilometers away. Okay, so now we are getting some like we are losing some intensity out of the light. Okay, that is coming from a light source or a single thing. So now the decrease in the light source is inversely proportional to the squared distance from the object. So how they are modeling this thing? So this thing, the same thing is model and can be given in this form. The decrease in the light source, the decrease that we are getting in the light source is inversely proportional to the squared distance from the object, and it decreases by 1 upon d, that is the distance from the light uh, and its square. So it can be given by this particular form. Okay, decrease in light source dl. Problem with 1 upon dl square. Okay, so now what is this thing? Too much intensity variation for objects that are close to the light source. Okay, too much intensity variation or that are close to the light source, too little intensity variation for objects that are far away, because it can create some sort of like unrealistic thing to your image or the thing that you want to illuminate or you want to display. So what it says is too much intensity variations could be there, and if your object is far, then also you could get some irrelevant things. So now instead of that, what it says is you try to put some constants. Okay, so use the following function instead. So that functions can be given as you can see over here. There is f attenuation dl equal to 1 upon a0 a1 dl plus a2 dl square. So now why we are using this constant? So it can be given by you, can be given based on the requirement. So if you give constant according to your requirement, so it will help you to adjust the it helps you to adjust the scenario, the things that you want to display to produce better attenuation effects. At the end, if I say to attenuation effect, then this thing should come in your mind that based on its position as compared or towards the light source or something, we are getting multiple intensities. So we are trying to adjust this thing so that everything looks a bit like more realistic. Okay, for a light source that is at infinity, we do not use attenuation. We can assume all the objects are equidistant from the light source and receive same amount of light. Okay, so now you might have some scenario or something to be limited where multiple objects are there, and we are considering we can put that objects if we have trees, multiple trees in our application. So what we can do is we can put it in this scenario where they will get equally light source and they would be able to give the same intensities that is the amount of light that is falling on that particular surface. So try to understand this thing. Okay, and that is how it will create that particular thing. And then directional light source and spotlight effect. Okay, so now over here a directional light source can be defined by a light direction v light. Okay, this is a light direction, and then angular limit. Okay, that is given over here. And then what it says, object outside the light cone will not be illuminated. So it's a simple example of a torch. Okay, whenever you are in dark, you try to turn on your torch and you try to put that light on the surface. Okay, so whatever things you are able to see, is based on this particular effect only. You are considering this thing that is a spotlight effect. So the cone or the thing that is being generated only will be it will only be illuminating the things where you are incidenting this thing, or where you are like falling this particular light, and the remaining things won't be able to illuminate. So based on the simple fundamental, it will do this thing. Okay, and then surface lightning effect. The light reflected from the surface on an object depends on the several factors. Okay, so degree of the reflectivity of the object. So over here we have shiny versus dull surfaces. Okay, as I said, if you are using a wooden block, now if I am saying that you have this capability, that is to model a shiny or a matte surface or a wooden block, but obviously that wooden block won't be able to illuminate that much amount of light. uh, and if you take a metal ball, in that case you'd be getting a different thing to see. So now to model the same thing, we have this kind of capabilities where you can actually model a wooden block. Okay, but obviously degree of reflectivity would be different in this case. And then surface texture properties. Okay, so you have this thing also in the real world, kind of whatever kind of like texture is present on the surface. It would be like at the end giving you some different intensity or reflection property. Color reflectance coefficient. Color of the object is also important, because if your object is a blue color or some something that you generally see, and if it is of that color, then you'd be able to model a similar kind of thing. Your blue object, it's in a certain position, and if you are incidenting your light at that particular surface, then you'd be getting some sort of different thing as compared to a simple black and white surface. So similar things are there in OpenGL, where you can give this properties, that is shiny and dull object and something. Okay. Uh, okay. So now the basic illumination model that we have in this unit includes three things, that is ambient light, diffuse reflection, and specular reflection, as I said earlier in this lecture. So ambient light, बहुत सारों को पता ही होगा what is this ambient light. Okay, because we are sitting in a room and we don't have any such light, and our tube lights are also off. You consider this case where we are not using any tube light or something, and our curtains are open. So then too we are able to see the objects that are present in our room, or wherever we are sitting. So these things are illuminated based on the natural lighting condition that is outside. That is not at all falling on our in our room, or we are not getting this kind of light in our room. But then too we are able to see this thing based on the natural lighting condition. And this category is nothing but this thing that we are talking about is nothing but ambient light. Okay, we generally talk about the ambience is good and something. So a natural thing you'd be getting. So the same thing is written over here. As you can see, reflected light from the environment and the nearby object cause other object to illuminate. Okay, so from the environment and the nearby object causes other objects to illuminate it. Okay, it is not at all getting like a direct light or something, but then too it is getting illuminated based on the background condition, based on the other things, also called background light. So you just keep one thing in mind: whatever things we are right now having, we are sitting in a room, we are not getting any direct light, but then too we are able to see this thing that is present, so it comes in this category. Constant color reflected from all the points on the surface. So you are not able to see a shiny thing or reflective things in your room, but you are able to just see the stable things that you have in the scenario. So that is nothing but the constant colors that you would be getting. And the same thing is given over here. You have multiple circles with different colors present in this diagram, as you can see. And this comes in this category, this ambient line. So you won't be able to see that much good effect if you just simply use this ambient light in your program. Okay, you'll be able to just see a dull circle or object, whatever object you are working with, and nothing, no reflections, no such orientations will be there. It tells us how bright the surface will look like when no source can directly reach the surface. The same thing. and when used alone does not produce very interesting pictures. Okay, so what programmers or designers try to do is they try to combine all of this lighting effect to create a more realistic thing. Okay, and how you can model this thing. So we can use, and as I said, like to do all of the conceptual things in OpenGL, we have simple functions. We have a single statement that you need to write, and with the parameters that are given to us, as you can see, modeling the ambient light would take this parameter as INK, and we'll see this thing. What is this INK? And once you put the value in it, you'll be able to see this thing. That is ambient light. Okay, very dull thing. We can use an ambient intensity parameter IA that describes the light of an ambient light in a scene. So that intensity parameter is termed as IA that describes the light of ambient light. Okay, so this parameter is nothing but that is the intensity that you're using. Okay, every object in the scene will be illuminated by this amount independent of the surface orientation and the viewer's location. Whatever viewer location is there, whatever the surface orientation is there, you just keep it aside. We are not considering this case as of now in the ambient light, and whatever things is there, it will remain as it is, and every object in the scene will be illuminated by the same amount instead of like being dependent on the surface orientation or something. Because if we talk about this thing, like a shiny object is there, and if you are getting that shiny spot and to see, so but obviously it is dependent on the light source as well as the viewer's location, and so many things comes into the picture. Okay, so surface orientation is also part of it, but different surface may reflect different amount of ambient light based on that absorbance reflectance property. You can model this thing by a constant factor for each surface. Okay, if you have like 2 or 3 such objects in your picture or in your model, then you can similarly change Ka for each and every such objects or such surface that you have used, and based on that it would be taking the same thing, that is its absorbance or reflectant properties. So then similarly you can model it. So nothing more interesting would be generated, but you'd be able to see a bit difference in color or something, but then you won't be able to, you're not able to see that kind of reflections or something. So next thing is diffuse reflection. As you can see, you are getting a bit more closer to realistic thing. Okay, and as compared to a dull round spot. So as you can see, yeah, the first line says that the light that is reflected in all the direction is called diffuse reflection. So you can like similarly whenever you read this slides, you try to understand this thing, because we can put this thing in the MCQs or blank form. Okay, and this time in the examination I will try to put kind of certain kind of constraints or certain things in the question itself, so that you don't put space, unnecessary space or hyphen or something, and everyone would be giving the same answer. Like in the end, like, again we will be in that particular situation where multiple people would be using multiple things. Okay, as I have like I don't exactly remember, in one question I already put that thing that don't use any parameters, so then too many students have used that thing. So you try to read the question properly. If that is to be, if one question is being formed by me, I will try to put all the scenarios that students will think about. So I will try to keep that exceptions in that questions itself, so you don't get confused. And then too, if anything goes wrong, then I'm here to help you. Okay. So now we have one topic, that is the light that is reflected in all the direction. Okay. So now we are getting this light that falls on the surface, and your light is getting reflected in all direction instead of like getting reflected at a particular spot or particular surface position. Your light is getting dispersed. Okay, totally. The reflected light is independent of the viewing position. So now it is not at all dependent of the viewer's position. Okay. So it is equally bright from all the viewing direction. Okay. So even if you see it from other direction or the spot, you would be able to see the same thing. Okay, that is how it is modeling it in the diffuse reflection part. Okay. So second thing is this, but the light position with respect to the surface orientation is important to determine the light reflected from the surface. Okay, so now as we have already seen this thing that now viewer's position is not important in this part, it is independent of the viewer's position, but now the surface orientation is important. Okay, why it is important? Because your surface could be oriented or it could be standing or some it could be positioned at a certain particular positions, and your lights might be falling on that surface and some of the lights might not be falling on that surface. So we will see the same scenario so that you'd be able to understand the same thing. Okay, and yeah, the same thing is in the next slide we will understand is how it makes sense, okay, with respect to the surface orientation, and we can determine this thing, the light reflected from this. Are you getting this thing? See, these are the things, the ultimate thing that we want to create something that we generally see in our day-to-day life, but now to do so we need something and we need some concept that we can use. Okay, see, whenever you go with the CG book, like by Hanin Maker, you will understand this thing that how things have they have written this thing makes sense. Okay, how different things are there, and how these authors have put this thing into the book, and similar thing is given. So, but the light position with respect to this is important to determine the light. So each and everything matters over here. So when an object is illuminated with the white light, the original color of the object is what we see as the diffuse reflection. Okay, one very simple fundamental that we already know. But now, if a blue object is illuminated with the red light, now our object color is blue and it is getting illuminated with red color, then it will appear black. Okay, so that is what it want to say. Like every small detail is important because at the end, we want to create a realistic thing, okay, which we can model, and if you have some time, like if you get some time, try to take some readily or some examples that are there on the internet where they have modeled this traffic light kind of thing, or this river and mountains thing, and they have made all of this thing in OpenGL. And even if you take this graphics.h library, they have created this models. Okay, so you can consider this because we don't have this mini project kind of thing. We cannot do all of this thing. Now, modeling the diffuse reflection. Okay, we know that thing. Okay, that two things are required whenever we want to model the ambient light, and for that we have this constant factor and ambient light intensity. So now over here, what more thing that we are getting is orientation of the surface determines the amount of light incident on the surface. As you can see, the second orientation, the same object is there, but the orientation is quite different, and our light source is getting through it. Okay, it is not at all falling on that particular surface. So now to model this thing, what it says is given the angle theta between the surface normal and the incident light direction, we can write the diffuse reflection equation as given below. So now over here again we have multiple things to model. If we have multiple, and we need this constant factor, and then this particular diffuse reflection, and then the incident light. Okay, and the same thing could be modeled with this cos theta factor, by which you can actually determine that how you have oriented that thing and how this thing would be there. Okay, now combining both of these things, now again, as I said, like you can combine all of the models that are present, and how you can do is you can just simply combine it to create a more realistic thing. So to do so, we have over here, as you can see, we have two such things. Okay, unit vector was the light source, similarly a normal vector, as you can see, perpendicular light that are coming out of a point that is present on that surface. Okay, and in between we have one angle that is theta. So now how you can model this thing? So if you have this angle, and if n into L greater than 0, then you can put both of these two things together and you can put it in your program also. That is nothing but KIA, that is ambient light. You have just added this thing, that is ambient light vector, with this diffuse reflection thing. Okay, and whole of this thing so multiplied with the, as I said, if I say it is independent, then you do not have to consider, but if it is dependent, then you have to consider all of the factors, that is all of the factors that are present. Okay, so orientation is present over here, so we need to consider this thing. And if it is getting less than 0, then you can just go ahead with this particular factor. Okay, and how you can get this L is nothing but P source minus P surface. Okay, so you can see the results over here. So we have two such things, that is ambient light versus diffuse reflection. Okay, you can see this thing after combining, or you'd be able to see the results, how good it looks. Okay, and if I say if you can put specular reflection 2 in the scenario, then you'll be able to understand, okay, this is the basic thing, this is the basic fundamental that you could put. Okay, and you can combine both of this thing. And then the next thing that we have is specular reflection. So as you can see at this particular point, okay, this is the thing that it can display. Okay, so similarly, we can use specular reflection to eliminate this kind of effect or to display this kind of thing on our computer. Okay, so now light reflected. What is specular reflection? Light reflected from a certain point and the object is concentrated and appears as a lot brighter compared to the other spots. Okay, so now as I said, like it is the earlier one was independent of the viewer's position, like whatever position you are viewing this thing, you'd be able to see the same amount of light that is getting reflected from that particular object. But now over here in the specular reflection, you'd be able to create a spot where you'd be getting like if your surface is illuminating or reflecting more amount of light and that spot comes into the picture, you'd be able to create a same effect in the specular reflection, as you can see in this figure. Okay, this figure. So now this is due to reflection property and is important property of shiny object. You might have a scenario where your like one mirror is there, or you have created one like lake kind of thing or river and mountains kind of thing, and you have one mirror at that particular position in your scenario. So, but obviously you'd be able to understand this thing now. Okay, we want something that will reflect a certain amount of light from that particular property. So to do so, we can use this specular reflection concept. So it is both dependent on the light source, surface orientation, and viewer's position. So now multiple things are over here, and we can similarly use this thing, okay, to model this particular thing. Okay, so now instead of this, if I say independent things are coming into the picture, then we have to consider all of the concepts that are there mathematically if possible. Okay, you cannot just put this thing or you can avoid this thing. So now okay, so let us try to picture specular reflection. Okay, so as you can see, we have multiple things coming out of a particular position. Okay, that is there on the surface. So now what it says is specular reflection angle equals the angle of incident. Okay, we are not like we are not looking at the thing that is getting incident on that particular surface and it is getting dispersed into in all the directions, but we are getting it in a single direction. So now over here, which are the things that we have with us are given over here. Okay, so as you can see in the figure, specular reflection direction at a point on the illuminated surface is given. Okay, and then we have a few things that we have to like understand. We need to understand is this thing, that is first thing that we have is the unit normal surface vector that is denoted with m, as you can see. Okay, And then the figure we have one more thing, that is R, to represent the unit vector of the direction of the ideal specular reflection. Okay, unit vector in the direction of the ideal specular reflection, L. Then we have L. L to represent the unit vector directed towards the point light source. Okay, and we have as the unit vector pointing to the viewers from the surface position. Okay, as I said, if these things are there in the concept, then you have to model sorry, you have to model it in such a way that everything is considered, and then that is how we can model this thing. And we have angle phi and angle theta. So angle phi is the okay, angle phi is the viewing angle relative to the specular reflection direction R. Okay, and similarly for an ideal reflector, suppose if I want to I want to model an ideal reflector, this perfect mirror, incident light is reflected only in the specular reflection direction. Okay, in case we would only see reflected light when the vector v and r coincides, that is phi becomes 0. So these are the basic things that you need to understand and you need to put into the consideration whenever we talk about specular reflection. And wait a second. So the specular reflection is visible only a direction close to R. Shiny surfaces like mirror have a narrow specular reflection range. So again, the same thing is over here. What you can do is similar kind of parameters could be set according to the surface that you are modeling, and at the end you can get that kind of effect. So that is need to be understood. And similar thing is over here. If v into r gets greater than 0 and n greater than, then you go to model it in this particular part. Why we have kept this thing ns over here is because based on the narrow specular reflection, because if we are using shiny surface like a metal ball or a mirror or something, then we need to give this parameter also. So if you are creating something, then you need to give all the parameters, and if you are using a programming language or some library that uses this kind of parameters or multiple things, if it is there in that function, then it will give you that, okay, these are the things that are necessary to put it in that particular part. So if I talk about specular reflection, and if you want to use a specular reflection in your model, then it'll be giving you this many things are necessary whenever you are modeling that thing. Okay. So likewise, we have this thing that is diffuse versus specular reflection. See, don't get confused with computer graphics and image processing thing. We are not at all with this image processing part. Okay, image processing is a totally different thing. If you say that, okay, I am interested in this image processing applications and I'm interested in that kind of projects or something, and then you keep one thing in mind, that is this thing that we have, computer graphics. It is totally different. Both of these things are different and they are totally different. So understand that thing. Okay. And this is how it looks without specular reflection. As I said, the diffuse reflection won't be the amount of light that is being incident on that surface will be dispersed in the multiple direction. But now we are like focusing on the spot that from where it would be giving you more intensity or reflecting more light. But obviously, if we have this property, then we'll be able to see the same kind of thing. Okay, as you can see on your computer screen. So that is diffuse versus specular reflection. And then similarly, we have such kind of things. As I said, like multiple intensities could be given to your surface. Okay, as you can see, like diffuse strength is given over here, that is 0.5. Similarly, ambient strength is given to it, is like some intensity has been given to this particular thing. okay, and that is 0.15, and the specular exponent is given 1. So likewise, it is based on that intensity. As I said, like if your this parameter that is given over here, this narrow specular reflection range. So if you give it 100, then be able to create like a small spot where it would be giving you a shiny thing, or more amount of light would be reflected from that particular spot. But if you give it a smaller value or smaller range, something, then it will be giving you this kind of effect. So it all depends how you are playing with your model, and how you're modeling it, so how you're putting it into the test. So this thing could be done by you, and you can generally check it. So as I say, you can take any of the model that is present, and you can put it to test it, okay, how these things are visible to you, and likewise you can understand it. Okay, so now whole of this thing in one slide. So that is the reflected light. The light reflected off the surface of an object is composed of ambient, diffuse, and specular components. Okay, as we have just now seen, and based on that concept, we can model our light that we can get out of that surface, okay, from that object. And then ambient component is independent of component is independent of the surface orientation and viewers position that you already know now. And diffuse component is independent of viewer position, but depends on the relative orientation of the light source and the surface. So I can model this thing, okay, and I can put it in the MCQ form. Like I could be giving you 4 options like A, B, C, and I'll put some statement in A, B, C, and D. And similar thing I can keep in the MCQ part, that okay, choose the correct statement, and in the option you'd be getting like the similar thing that you did in JEE, or as you've seen UGC NET or GATE. Okay, you can model the same question, and in that you have to answer the correct choice. You have to choose the correct one. Okay, in specular reflection, the position of the viewer is also important. Okay, these are the things that you need to understand, and that we have. So next we have with us is this polygon rendering methods. I don't know in the practical week you are going to come or not, but we try to like go accordingly, because we have 3 plus 3 6 lectures remaining, and we'll see this thing. I think we'll be able to finish all of this thing. Okay, so next is polygon rendering methods. So surface representation. Yeah. So now we are moving towards something that is known as polygon rendering. Okay, polygon rendering matters. So it is also like a very important part of your of this particular topic. Okay. In that we have the shading models. Gouraud shading is there, then Phong model is there, and similarly normal interpolation rendering. And once we finish this thing, we'll. So we have very few things that we are going to learn actually. Okay, so we can start the same thing in the next lecture that we have Tuesday. Okay, this next Tuesday. Fine. So in total, we have seen so many things till now, and everything has been uploaded on the classroom or on the Moodle, so you can start reading it. Okay, try to, if you are not getting it from the, because PPTs are always abstract, because we need to go in that manner only. So if you're not getting any such topic, or if you're getting it is fine. It's not like that, okay, everything is to be very perfect or is to be very good. It is fine. If you're not getting it, is completely fine. You can refer the same thing like in the book, and the CG book that we are referring, Hanan Baker is very good. Like so many things are given. Though they have abstract thing, you won't be able to find the numericals or something. But 10 to it is very good. Conceptually, everything will be clear to you. Okay. So yeah, that's it for today. If you have anything to say, you can write. So we can stop our lecture.